main engine start. 2, 1. Booster ignition and liftoff of Discovery, celebrating its 25th birthday by racking up science and supplies to the space station.
Houston now controlling the midnight ride of Rick Sturckow and his crew to the International Space Station. Discovery rolling on to the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Outpost. 32 seconds into the flight. The 3 liquid fuel main engines soon will throttle back to 72% of rated performance down in the bucket, reducing the stress on the shuttle as it goes transonic.
T-minus 10, 9, 8, 7, 6, 5. We have ignition of the RS-68 main engine. 1, 0, and we have liftoff. Liftoff of the United Launch Alliance Delta IV rocket carrying the 6th GPS-2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users. You're now hearing the voice of Tim Holt providing launch vehicle ascent data.
Vehicle control appears nominal. Mach 1.
Pretty impressive, right? Getting to space is impressive in rockets. So how does a rocket engine work? Rocket engines turn fuel into hot gas. The engine pushes the gas out its back. The gas makes the rocket move forward. There are 2 types of rockets. Ones that burn liquid fuels like the Russian Soyuz, and ones that use solid fuels like the fireworks and the model rocket we made earlier.
That was much better this time. Wow! Cam started. I think I see something leaking out of the bottom. Much better.
Woo!
All right.
Saw it? So why does a rocket work? In space, an engine has nothing to push against. So how do rockets move there? They work by a scientific rule called Newton's third rule of motion. For every action, there is an equal and opposite reaction. Check out this clip for an explanation of this rule.
Welcome to the European Space Agency, ESA. Newton came up with 3 laws of motion, laws that describe how forces and objects relate to each other. Hi Pedro, Alexander. We can see that they're floating. They're pushing against each other and move apart. That's an ISS battery and it looks heavy. That means it has a lot of mass, right? Once again, they're pushing against each other, but Alexander moves less. What we see this time is that for every action, there is an equal and opposite reaction, Newton's third law of motion. Alexander pushes against Pedro, action. This causes Pedro to move, reaction. At the same time, Pedro pushes against Alexander, action, causing Alexander to move in the opposite direction, reaction. And they moved an equal distance, action equal opposite reaction.
So using Newton's third law, a rocket works like this. A rocket pushes on its exhaust. The rocket pushes the exhaust backwards. The exhaust makes the rocket move forwards. Have you ever noticed what happens if you let the air out of a balloon? The air goes one way and the balloon moves in the opposite direction. Rockets work in the same way. Exhaust gases coming out of the engine nozzle at high speed push the rocket forward. Sending a rocket into space does involve much more science and engineering. But if you are a budding engineer looking towards a career in rocketry, it all starts here with Newton's third rule. For every action, there is an equal and opposite reaction.